Yes, class. Am I audible to all of you? Alia, Austin, Faiza, Pia, Humam,
Yes, ma'am.
Shahid,
Yes, ma'am.
Javed. Okay. Now see class. In the last class, we had started with alternating current. So I had told you what's the difference between an alternating current and direct current. So direct current was a constant current, which you have been using. Like if I tell you I is equal to 3 amperes, that's a direct. But if I tell you the current is varying, suppose I tell you the current is 3 sine omega t, that becomes an alternating current. So alternating current, basically the current varies sinusoidally with time. Sine curve we have also seen. Now the concept of AC generator or dynamo. We are starting with this. Actually, this in some books you will find this as a part of EMI also. At the end of the lesson of EMI, AC generator is sometimes included. But though the entire concept is based upon AC, alternating current, so we are discussing it in AC. So depending upon your school syllabus, please just check it, whether if it's just covered in EMI, then all those who are preparing for till EMI in their half yearlies, please let me know. Other thing, I had asked all of you to send your date sheets on WhatsApp. Nobody has sent, because it's very difficult for me to remember each and every date you people just say in the class and your syllabus. So please send your date sheet by tonight, whatever date sheets you are having for the exam. Otherwise, I'll not be able to arrange for your extra classes also. I'll not be able to arrange for with the syllabus. All right. Now, what is AC generator or dynamo? It's basically a device. Now, it converts energies. It is a device that converts, see, mechanical energy. What is mechanical energy? Mechanical energy is the sum of kinetic energy plus potential energy. So it's a device that converts mechanical energy into what? Into electrical energy. It's a device that converts mechanical energy into electrical energy. Mechanical energy means through movement. Acha Shavaz, you have not syllabus yet. Okay, fine. Whenever you get, then update me. Whenever you get from the school, just forward it me on the group. Okay, so what's the principle that the AC generator is based upon? Same, EMI. This is actually connected to EMI a lot. I'm telling you, this in some books, this is a part of AC generator itself. So it is based on Faraday's laws of EMI. What were the Faraday's laws of EMI? Whenever flux will change, EMF will be induced in the coil. And second law, this was the first law. Second law was EMF that is induced is directly proportional to rate of change of flux. So based upon both these quantities, your entire AC generator is based. Now, what is exactly what is an AC generator, right? What is meant by it, what type of device it is. If I'm saying it's a device, it means it has parts, it will be having a certain construction pattern which will be followed every time. So it's a device. If it's a device, it will be having certain construction pattern. Whenever flux changes, yes, your EMI normally your laws of EMI minus G5 over T. In an AC dynamo, magnetic flux gets changed due to rotation of coil in uniform magnetic field. This you will understand first. You see its structure. See how it's constructed.
Ma'am, AC generator means alternating current generator.
Yes, yes. AC generator means alternating current generator or alternating current dynamo. Dynamo is just a term that is mentioned. You will understand it. See what it is construction. You have two magnets, north and south. These are again permanent bar magnets. These are permanent bar magnets. They are kept. Now, magnetic fields direction with these magnetic field lines will be existing. From the north towards the south, these are magnetic field lines which are existing. Fine. This is the coil. This is a coil that is kept. This is a rectangular coil that is kept. Now this coil is attached through slips. All right, these slips are present. This is a slip that is connected. All right, and these are two slings. These circular portion, you are able to see this and this. They are actually two slings which are connected. They are just able to rotate, allow rotation. The way we have screw drives, but screw drives are fixed. They do not rotate once you fix them. These are like screw drives, you can relate, but they are movable. They also move. So these are slings. Two slings are attached. And finally, these slings are attached to what? This is known as an ammeter. All right, this is known as an ammeter. This is how it is constructed. Now what happens? See, this rotates. This coil rotates. Now come to your line, which we were studying. In an AC dynamo, alternating current is present. If alternating current is present, you know how the current will change. The kind of graph we'll get is this. This is the kind of graph we will get. So in an AC dynamo, means current is variable, you are getting sinusoidal curve. Magnetic flux changed. Magnetic flux changes. Magnetic flux changes or magnetic flux gets changed due to rotation of coil in uniform magnetic field. This starts rotating. This is a uniform magnetic field. The coil starts rotating in the presence of magnetic field. And now see class, after studying the entire magnetism, you will not be surprised why is this coil rotating, right? You already know the reasons. Changing magnetic flux, entire law. AC dynamo and AC generator are not different. It's just one more name given to AC generator. Dynamo or generator, both of these are same. It's just that in some books, in some questions, you will be finding this. All right, so when this is rotating, magnetic field is present. Circuit should be here. No, which circuit? Bar magnets are already present for magnetic field. And haven't you studied about torque and the motion that occurs and magnetic flux, changes of magnetic flux? So that is enough. Why circuit? If circuit is already there, then there is no concept of AC generator. It is converting the mechanical energy, means the energy that is required by the coil to rotate. The potential, magnetic potential energy U is equal to MB cos theta that is occurring. That energy, it is converting into electrical energy. If already electrical energy is existing, if we already have the circuit, if already circuit is present, then why do we need to convert mechanical energy into electrical energy? Then directly we'll be having electrical energy. In order to utilize the alternating current, we are converting this. We are specifically converting potential energy in kinetic energy. Kinetic energy because of movement of coil, half I omega square. Remember in class 11th, you people must have studied moment of inertia. So it's half I omega square. I is the moment of inertia. And potential energy because of magnetic field, you have studied magnetic fields, potential energy also, MB cos theta. So both of these energies that are being produced combined, they are getting converted into electrical energy because of the graph that we are getting, because of the rotation in the coil. You will see how. You will see through the formula, through EMI only, means Faraday's laws of EMI only. See, let me tell you that. This is the basic construction. Suppose N is the number of turns in coil, A is the area of coil, B is the magnetic field, omega is the angular velocity. So here, how do we write phi? B dot A. Remember, phi magnetic flux is B dot A. That is B A cos theta. Correct, class? And if N number of turns are there, so that becomes NBA cos theta. Class, remember, you always have to start this derivation from here. NBA cos theta. Because you will be confused sometimes that we write it as BA, B dot A. So should we just not start with BA? No. Cos theta will also come, N will also come. And only this theta will help you bring your omega angular velocity. Theta is what? Theta is actually nothing but angular displacement. Theta is nothing but angular displacement, right, class? Now see, when we write NBA cos theta, omega is what? Angular velocity is angular displacement by time. Right, class? Angular displacement by time. So theta becomes omega t, and this is how omega t gets introduced in your every calculation of AC. You will be seeing a lot omega t, B sin omega t, E sin omega t, E cos omega t, I sin omega t. That's how this is introduced. Fine, NBA cos theta. So theta you can write it as omega t. So your phi will become NBA cos omega t. EMF value, this is minus d phi over dt according to Faraday's laws. Put the value of phi. This becomes minus t NBA cos omega t over dt. All right. NBA cos, we are differentiating it basically. Anyone who remembers how to differentiate cos theta, cos omega t? Anybody who would like to answer? Or you already know? Cos omega t you are differentiating. Minus sin theta minus sin omega t. Minus sine. Okay, I got it. Minus sine theta, basically you're saying that, and theta here is omega t. Correct. All of you are right. Just one thing, class. Just one thing. Whenever you are differentiating sine or cos function, no, with a constant in between, your angle has a constant. This is a rule of integration. Just check it once. All the students who are having maths already, you can check. And for other students, I am only telling you, just remember this fact. Whenever you have concept like sine omega t, or you have the concept like cos omega t, in between you are having this constant omega. Omega is a constant. So when you differentiate this, this becomes omega cos omega t with plus minus whatever is. This will be plus. And when you differentiate cos omega t, that becomes minus omega sine omega t. If there is a constant in your what do we say, angle. All right, usually we have sine theta. For sine theta, minus sine theta is fine. But when you have sine omega t or some xt, sine phi t like this, then you can take. Because theta is a constant, theta is a variable quantity. We know angle changes. Sine theta, that changes. So we write it as plus cos theta. Or cos theta, we write it as minus sine theta. Yes, that's the rule. That's how you people have answered to me also. That is correct. But if in your angle, some constant is also involved, then you bring it out. The way we differentiate, no, if I give you 3x square, how will you differentiate? You will bring 3 out first. Then you will differentiate this as 2x, right? And then ultimately you will multiply. Same happens with trigonometric functions. So here, NBA is a constant. So your EMF will be minus NBA. This is a constant. And your cos omega t becomes minus omega sine omega. So minus minus is becoming plus. That makes it NBA omega sine omega t. Fine. Now see, what all, this is the equation. This is the equation on which AC.
Omega is constant.
Yes.
Omega is constant.
Omega is constant. Omega is constant here. Angular with one particular angular frequency, it is revolving. Angular velocity, 5 radian per meter square is held. Then it will 5 radian per second square is held. Then it will be rotating with that only. Okay. Flux is variable. Here the flux is variable. That is why, because of which your magnetic field is produced. Otherwise, omega is a constant. That's why we have used this. For this concept, that's why we have used this. One thing I was saying, see, this is the value of EMF that is produced when you are having what? AC dynamo. which is converting the energy. The electrical energy is produced. See, if you have, when the electrical energy is produced, you will be having potential difference also. That is EMF also. So NBA omega sine omega t is the equation. But many a times you get a one maximum value of EMF is present. One maximum value of this EMF. No. See, now this is a variable EMF. Can you notice, class? Can you tell me if this EMF by any chance is a constant? If you change the first thing that you will notice, you will tell me N is constant, number of turns are fixed. You will tell me magnetic field is also constant because angular frequency, that is angular velocity omega, is constant. Area of the coil will also not change. So how this is variable? Time. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, infinite. You can change the time. EMF is now a variable quantity. Do you see the effect of alternating current? Entire answer is changed. Entire answer is changed. You had so many equations for EMF. You had motional EMF also. You
As
studied.
time increases, flux, EMF will increase.
This is, yes, the electrical EMF. Yes, this is the electrical EMF. Electrical energy is produced. So you will be having current, you will be having EMF. These two things will be fixed, right? Current and voltage only make up the electrical circuits because resistance is always constant. You put a fixed value of resistor usually, unless and until it's a rheostat, right? So that's why this now, see, a drastic change has come in your answers, in your calculations. Earlier, you used to just put a single value of EMF, right? 5 volt, 6 volt, 7 volt. Now this is variable. This will be changing. So what is the maximum value? If I put this as 1, T as 1, then 2, 3, 4, 5, something. How will I get the maximum value? I cannot put this as which number should I decide? 100, 200? No, I cannot choose any number to get its maximum value. But what we can do? This is sine theta. We can at least get the maximum value of sine theta. Theta is what? Omega t. So we'll have sine theta, that is sine omega t's maximum value, as 1. Right? It means your theta, that is omega t, omega into t, is 90 degrees. So what is the maximum value of EMF? NBA omega. This is NBA omega. All right. One more thing,
Ma'am,
class.
how magnetic field is constant?
Magnetic field. You're asking
Like
about magnetic field.
yes.
Yes, magnetic field is also constant. See, at a certain value, you are doing this calculation. When this is fixed, this is fixed, this is fixed, this is fixed. When flux will change more, this will become something else. This will also same at the same speed. So ratio will again become constant. Only variable here was time. That was changing continuously. See, the way you have no EMF, you will have I also. Current, when you have no current's value also, you will get it as I. This I'll tell you though. But just for a rough idea, if you are having E as E naught sine omega t, so your current will also become I naught sine omega t. I'll tell you what is this E naught I naught. I'll tell you later. Just forget this right now. I'm just telling you that current will also be variable like this. So this is the maximum value. So if this is a sine curve, EMF is varying sinusoidally. Can you see sine is coming in your answer? So that's why we have alternating current. Now see what type of graph we'll obtain. Variable graph. It's a sinusoidal graph, first point. Sinusoidal graph. It is varying sinusoidally. Why? You have the proof now. In the last class, I was just mentioning. Now you have the proof. This is the sine curve. Right? Sinusoidally, it's varying. And there is a maximum value that is achieved. What is this maximum value? This maximum value is NBA omega. This is the time period, total duration that takes to complete one cycle. This is known as time period. 1t, whatever time it takes for this one wave to complete. Then this is minus. This is what is the entire concept of your AC. That's why I did not do this in EMI, because this is much more clear in your alternating current. Note this down, class, whatever doubts you are having in between us, because now a lot of calculation part and derivation part will come. So before that, get your basics clear, then the derivations won't be so difficult. Did you people attempt the test that you had yesterday? A revision
No,
test?
ma'am. Actually, yesterday there wasn't test, ma'am.
Acha,
Some
yeah, it was
technical issue.
cancelled, no? Okay, ठीक है.
Yes, and there was
Ma'am, exactly how the AC dynamics works, ma'am? How does it rotate?
Yes.
Ma'am, how does the AC dynamo rotate?
Yes, the AC dynamo will rotate.
Yes, ma'am.
His coil will rotate.
Yes,
Are
ma'am.
you asking something, Fia?
Yes, ma'am.
You've drawn this, all of you. Should I scroll?
Ma'am,
Yes, Fia.
Yes, ma'am.
ma'am, can you once again explain how does it turn, rotate?
See, torque. Remember you studied torque in magnetic field, that concept. Magnetic field will be existing because you have kept the magnets. So it will start rotation because of torque. Okay, that's the reason. Nothing difficult on you. And the apparatus is also very simple.
So sling will also rotate, right, ma'am?
Hmm?
Sling will also rotate, right?
The slings will also rotate. That's why they are not screws. The slings will also rotate.
Ma'am, can you scroll up?
Yes.
Can you scroll up, ma'am?
Yes, Fia, say. Done till here? Okay, now see average value of AC for half cycle. Half cycle means, see, I told you, this entire time period for one entire cycle, this is one cycle. One sine wave is known as one cycle. So one cycle has time period. So half cycle means this part only, that is time period becomes half. So we have to apply integration over here for finding out the average value of AC for half cycle. See, current's value is I naught. I naught is the peak value. See this value, no? E max. This can be written as E naught, peak value or maximum value. NBA omega. So that's why in the equation, we can write E as I naught, sorry, E naught sine omega. This entire term is E naught. So you can write this as E naught, replacing E max as E naught, sine omega t. And if E is this, so you can write I also. I is equal to I naught sine omega t. So what is I naught? Again, peak value. You will be having peak value also. You will get the name amplitude also. Remember in your waves and oscillations in the last lessons of your 11th class, you people must have done waves and oscillation, SHM and waves. So there you must have studied what is meant by an amplitude. Amplitude is the maximum highest displacement that is covered by a particle in a graph. So that's why we can call this I naught also as amplitude. All right. And also maximum value, because we know peak value is itself a maximum value. All right. So what is current? Current is dq over dt, rate of change of charge. So what is charge? Charge is I dt. This is I dt. So to find out the value of charge, we'll integrate it. We'll integrate, yes, to get the maximum value. And current will be integrated from 0 to t by 2, because this is half cycle only. So when you're integrating this, q will be equal to I, what can you write I naught sine omega t dt, integrating it from 0 to t by 2. Right? Now, how will you integrate sine omega t? How will you integrate sine omega t? This becomes minus cos omega t. Now, again, omega is a constant. So when you differentiate, this gets multiplied. When you integrate, this gets divided. I have told you now, when you are multiplying it, omega will come here. This will get divided in this case. All right. So I naught is a constant. You are integrating it from 0 to t by 2. The values, integration we have done, we just have to put in the limits. So what are the limits? The limits are from 0 to t by 2. Clear? When you're differentiating, this becomes minus omega sine omega t. When you're integrating it, this becomes minus cos omega t divided by omega. Remember the rules of integration for the trigonometric values. All right. Now we have these values. Let us substitute it. I naught, you can take it as common. When you are taking I naught as common, omega's one formula is, you people know, 2 pi by t. So let us substitute this 2 pi by t. 2 pi will be here, time period will go up. And let us put in the values. Cos omega t by 2. So omega t by 2 minus cos, this is 0 degree. This is 0. Fine. So this will, see, cos 0 degree, this will become 1. And let us substitute again this as 2 pi by t. So I naught t by 2 pi. This will become cos 2 pi by t into t by 2 minus 1. So tt will be cancelled, 2 will be cancelled. Cos pi, that is cos 180 degree. What is cos 180 degree? It's minus 1. Then you have this minus 1. This is I naught t by 2 pi. This is I naught t by 2 pi. So, and this minus sign is also there. No? One minus sign is also there. So this becomes minus I naught t by.
Pi gets cancelled.
Hmm? This minus sign is already there, no? This one. This one. This is already present. Minus 2. So 2 get cancelled. Yes, this minus and this minus will get cancelled. So you will be left with charge will be equal to I naught t by pi. Right? If this is the charge, what will be an average value of current? Charge divided by time. Here the time is t by 2. So see, I naught t by pi divided by t by 2. Tt will be cancelled. So what is the average value? Average value, you're getting it as 60.637 I naught, and E average will, why 0.637? Value of 2 pi I have calculated and told you, 0.637. Or you can directly write it as 2 pi I naught, or 2 I naught by pi. Similarly, E average, this will be 0.637 E naught. These are the values for half second. Quickly note it down. Done, class?
Yes.
See, if it's for full cycle, then the only change that will come is in the integration value of time period. Instead of integrating it to 0 to t by 2, you will be integrating it to 0 to t only. So from here, the differences will start coming. This will be cos 2 pi by t into t, right? Cos omega t minus t. See, cos omega t minus t, that will be the same. Yes, exactly. We are just changing the value of time. So cos 2 pi, this will be plus 1. This is minus 1. So this becomes plus 1. And you don't need to solve anything further. 1 minus 1 straight away. Nothing will come till here. This will just be, here only you will have your answer as the EI0. And quickly note it down. Anything can come for the derivation. Both of these come. Note it down. Okay, class, the next topic is RMS value, but that will take a lot of time. In the next class, we'll complete it tomorrow. And tomorrow only we'll start with phasors also, because just one topic is left from this. Questions also we'll do it tomorrow. So please revise these formulas and come. All right, this one, earlier one, which we did, this one. Okay, class, so thank you so much. Tomorrow let's meet. And Fia,